Hello everybody and welcome to, Flux for Professional Creatives. Today we'll be taking a look at Flux, the new image generation model developed by Black Forest Labs that seems to be all the rage in the generative AI field right now. But is the hype actually warranted? We'll be taking a look at Flux from a professional point of view. We'll see what we need for it to actually integrate in professional settings properly, and we will take a look at a couple of workflows that I have drawn up during the week. All, of course, from my point of view. For those of you who don't know me, I am Andrea Baioni. I was a fashion photographer, and I have been working with generative AI for a long time now, since before DALL-E 2 came out, and most of my work right now involves using generative AI in order to create workflows for fashion photography, product photography, and in general media production. So whenever a new model is developed and released, of course I am excited. Moreover, if it's a very good model like Flux seems to be. But first of all, what is Flux? Why are there 2 or 3 different versions of it? And who is Black Forest Labs? The first thing you gotta know is that Flux is a new base model that has been developed by Black Forest Labs, which comprises some of the engineers that were behind the creation of Stable Diffusion and Runway ML. So they got a fantastic pedigree. It's kinda hard not to see Flux as the response to the failed ST3 launch, both in terms of results you can reach with it, and in terms of actual architecture, and in terms of services. Back in the day of SD 1.5 and SDXL, usually only one model came out, and it was accessible at first via API, and then the weights and the base models were released to the public. Whereas with SD3 first and Flux now, we've got a plethora of different models. What was released to the public in terms of weights and checkpoint was SD3 Medium, but anyone could get access to other versions of it via API, and Black Forest Labs created something along the lines of that as well. So they have created and released 3 different versions of the same model. Right now, as open source models, we have the Schnell version, which means fast, and the Dev version. Schnell is basically an hyper version of the model, whereas the Dev is the full model. Then we have the Pro version, which is only accessible through API. We'll see how this differentiation between versions actually impacts professionals. But for now, let's just say that depending on your hardware and needs, you might want to look at the Schnell model if you're looking for something lightweight, well, as lightweight as this big of a model can be. Or if you're more interested in a more complete model, you want to take a look at Dev, or you can just download both and be done with it. I won't be talking about the Pro version because I'm not interested professionally in API-only models. And I will guide you through the installation of both Schnell and Dev later on in the video. But first, what do I, as a professional, look for in a model? And why do I think that Flux, while very interesting and very good, is not quite there yet? Well, first of all, let's say I, as a professional, have a high hierarchy of needs. At least when it comes to generative AI, what I want to do is have a great base model and then have control over how that base model behaves in my generations. So that usually means ControlNets, LoRAs, IP adapters, everything like that. For me personally, ControlNets and IP adapters come before LoRAs, and after all that, there's fine-tunes and all the extra stuff that I might need in order to get a job done. So custom nodes, different kind of models like hyper models, etc, etc. In this case, the base models are absolutely great, and that's why I'm here trying to make the jump from Stable Diffusion to Flux. Otherwise, I wouldn't have taken that into consideration at all. But in terms of control, we are not quite there yet. We have the first few control nets that have been created by external teams, such as XLabs AI, ControlNet Kenny for Flux, which is a start, but I find Kenny to be quite hit or miss. I'd rather have depth, for example, or line art. And some of you might want to have open pose as well, but that's easily solvable, because if a ControlNet can be created for this kind of models, then more will follow, and soon we'll have a full suite of ControlNets. We are missing an IP adapter still, which will come in due time, no doubt about that. And we have a mix of the first LoRAs that are coming out. But that takes me back to what I was saying about having different versions of the same model. Right now, we have different development paths for these different versions. So, for example, the ControlNet Kenny that we have here only works with the full dev version. so the FP16 version of it. But also these same devs have released a Quantized, that means smaller, version of Dev as an FP8 version, and a collection of LoRAs that only work on the Quantized version, so the FP8 version, and not the FP16 version of Flux Dev. And all of this doesn't work on the Schnell version, or at least it's not guaranteed to work. That creates uncertainty in what I can and cannot do with things. And professionals usually don't want uncertainty. I think it's still too early in the whole process of development of a new base checkpoint to properly address whether one model or the other is going to take the cake and it's going to be the standard, because that's decided by the open source community development as time passes. So I am sure that in due time we'll have a clear understanding of what's possible in one sense or the other. But right now, as a professional, I cannot work with Flux because of the mishmash of different releases that are accompanying the release of these base models. And going back to the results that we can expect from Flux, while they are mostly great, as you can see here, we are getting a very nice image out of a very basic pipeline, which is just a load image node with a ControlNet canny and then a simple text prompt. But this model has been trained in such a way that is incredibly narrow in what it accepts and generates. For example, it will not accept anything with weird dimensions. So if I change the dimensions here to 1280 on the long edge, this would happen. And that's because it doesn't accept that size for an image. Or if I tried another size that gets actually passed through the K-sampler, like 1536 in this case, I would get this horrible result over here because it's not the proper image size. Or if by going back to 1024, I would up the ControlNet strength to, let's say, 0.85, I would get this mess instead. Or if I reverted to a good ControlNet strength, that, by the way, is nowhere to be found in documentation. You have to find that out yourself. And I changed the Flux guidance, more on that later, to the standard value of 3.5, I would get another horrible result. And why is that? That's because the ControlNet has been trained for a Flux guidance value of 4 instead of a standard 3.5, and so it accepts only that value in order to work. And you can see here that we get the original image right back, a good image. All of these values are nowhere to be found in documentation. And this is honestly quite disappointing, because if this was 2 years ago, 3 years ago, where documentation was basically non-existent, and we were all trying to understand generative AI models together, starting from absolute scratch, then yes, of course, we wouldn't expect to know as much as we do today. But coming from a finished product like 1.5 or SDXL, a well-known product, and jumping right into Flux, I can see how a lot of users are having some frustrations about what's working and what isn't, because they have absolutely no idea that the things that they're used to when using 1.5 or SDXL are just not doable with Flux. At least not in the same way. So all these things considered, I think that Flux still has a long way to go in order to be production ready for professionals. Another thing that for professionals might be quite important is the license. Schnell has been released with an Apache 2.0 license, so that makes it basically freely usable for anyone in the world, regardless of what you want to do with it. You can fine-tune, use it, distribute pictures, whatever. But the dev version has been released with a non-commercial license. And we can see the two differences here in the GitHub page. Now, I don't want to let you go through all of the license with me here today, but the main point is that the non-commercial aspect of the license covers, fine-tunes, derivative works within the model itself, whereas the outputs cannot be legally covered by the non-commercial clause. So you are free to use the outputs, that is the generated images, commercially, but let's say you wanted to fine-tune a model on the dev version and sell that, you couldn't. And while that is absolutely fine, I think there is a bit of a gray area, at least within creative agencies wanting to use Flux-based workflows and sell the outputs. I personally would think that that would fall under the commercial fair use of outputs, but I can see how the use of the model itself, which is non-commercial, in order to get to those results could be interpreted in a more restrictive sense. So while I would appreciate a bit more clarity on that aspect, I think that this license is pretty well written, at least when compared with the original SD3 medium license. But that brings us back to the different version problem. From a purely commercial license point of view, we would absolutely want to go ahead and develop on Schnell. But right now the space is developing a ton for the dev version instead of Schnell, which is apparently harder to work on. So now for running and installing Flux on your ComfyUI instances, there are a plethora of different Flux models. You've got the two original models, the Dev and the Schnell by Black Forest Labs, and then you have quantized versions, like the one from X Labs, or the quantized version by the guys over at ComfyUI. The main difference is that the quantized version work on lower VRAM cards, and so they require less hardware specs. But in order to do that, they sacrifice precision, so it's all just a trade-off that you have to be wary of, depending on the hardware configurations you have and the complexity of the workflows you want to create. In order to download and install Schnell, for example, you would need to go to Files and Versions, download this savetensor file over here, that is flux1schnell.savetensor, in your UNet folder, and that's ComfyUI models UNet. The same goes for dev. You would need to place the Flux1 dev savetensor file in your UNet folder. Whereas if you wanted to use a quantized version of dev, for example, that is using FP8 as mixed precision rather than FP16, you would download it over here on this link in the description below and place this model in the checkpoint directory. So that's ComfyUI models checkpoint. The quantized version already comes with the clip models and the VAE model already embedded. But for the Black Forest Labs, the full precision original models, you have to download the VAE and the clip models independently. So for the VAE, for example, for dev, you would go here and place the diffusion PyTorch model.savetensor, maybe rename it to VAE dev, and place it inside of your model's VAE folder. And the same goes for the Schnell version. You download this model, rename it to VAE Schnell, for example, and place it in your model's VAE folder. Then you would need to download the clip models as well, which are the text encoders. And why do I say models instead of model? Well, up till now we're being used to one clip text encoder model only for 1.5 and SDXL. But starting from SD3 and Flux as well, we use two different clip models. And that's the clip-L.savetensor model and the T5XXL savetensor model. Now you only need the clip-L savetensor and either one of the two T5 clip text encoders. They have two different mixed precisions. One is FP16 and it's much bigger. The other is FP8, so you're sacrificing precision in order to run a lighter model. You can download either or of these two T5 models, but regardless, you want to place both the clip-L models and the T5 models inside of your models clip folder inside of your ComfyUI directory. So just as a recap, the original Black Forest Labs model go inside of the UNet folder over here. The quantized version of the models, like the ones from Comfy Anonymous, go inside of the checkpoint folder over here. The VAE, if you are running the non-quantized versions, go inside of the VAE folder. And the text encoders, again, if you're running the non-quantized versions, go inside of the clip folder. But how does that all translate into running Flux on ComfyUI? Well, first of all, you have to update your ComfyUI, and that's usually done by opening the folder that ComfyUI is in with the terminal and type in git pull. This will update ComfyUI to the latest version, the one that accepts Flux. Then a basic workflow with Flux would look like something like this. At the top here, we have the dev version, full FP16 version by Black Forest Labs. And at the bottom here, we have the Schnell quantized version, and that's the version by Comfy Anonymous. We can see one main difference here. At the top, we have the VAE, the model, and the clips loaded all separately, whereas at the bottom we just have the load checkpoint node with model, clip, and VAE all loaded at the same time from the same place. Everything else is basically the same seed, same CFG, same values, and these are the results. Of course, the dev version is miles better. But hey, the Schnell version is basically a hyper version, so that's to be expected. Let's start by looking at the dev version, non-quantized, because although more complex, it lets us understand how Flux works at least a bit better. So first of all, you want to load the VAE. I have renamed mine to Flux _dev_VAE just to catalog it better. You want to load the diffusion model by using the load diffusion model that brings the models over from the unit folder instead of the checkpoint folder. And then you might want to take a look at the weight D type. With a 4090, depending on the workflow I am running, most of the time I have to downgrade to FP8 for attention, otherwise I run out of memory. And that's with a 4090. But depending on your hardware, you might be lucky and just choose default, which is the full FP16 attention, or you might want to downgrade to FP8. Then you have the dual clip loader, and that's because you need to load two different clip models separately at the same time, and that's the T5 model. I am using the FP8 version in order to not run out of memory, but you can use the FP16 version as well if you don't run out of memory, and the clip L model. And you want to change the type from SDXL or SD3 to Flux. Then we have the text prompt field. Now you can use two different types of text encode. You can either use the regular one, which is this one, and then add a Flux guidance node, or you can use a clip text encode Flux node, which separates clip L and T5 prompts into two different areas and has the guidance already embedded in it. So you don't need the Flux guidance node as well. Then we have Flux guidance. Guidance affects how closely the prompt is followed, and we are still trying to understand what's going on with the Flux guidance and CFG in general with this model, because as we can see from early text, Flux guidance and steps are both very intertwined and they make huge changes without any continuity between different stages. Sometimes it feels more random than what we were used to up till now. Then you might have seen in other people's workflows a different kind of sampler, one that uses all separate models for schedulers and samplers and CFG and such. But let me assure you that the regular case sampler, the good old case sampler, works the same as with any previous models. The only thing that you have to keep in mind is that the CFG must always be at 1. This model was trained in order to basically ignore negative prompts, and that happens when CFG is at 1. Now, there's a way to brute force negative prompts, but that's still a thing that's being developed, and I don't want to overcomplicate things today. Then you have your latent image, and as I said before, this model only accepts very specific width and heights. So for example, if I change this to 1322, a random number, for example, it would get changed to 1328 automatically in order to get a size that is workable. Now, that is not an issue when you're working with amply latent images, but that's definitely an issue when you are working with image to image, for example, with VAE encode. So you would either need to know all these different values and resize the image first, or employ some way to resize the image to width and heights that Flux want to work with. And that's basically it for a very simple text-to-image workflow with Dev. The quantized version of these Flux models is basically the same, except that you are using an all-in-one checkpoint that has both the model, the clip, and the VAE models all embedded together. So you don't need to load all of this separately. Everything else still stands, but in this case, since we are using Schnell, we are only using 4 steps. And once again, if I input a very weird number, it gets resized to the nearest number in order for it to work with Flux. And this is the result we'd get, for example. Now, as you can see, the results we're getting are absolutely astounding. They're very good. And that's why I'm so excited about this model, that the results right out of the box are absolutely amazing. Moreover, if you think that this is a base model. But what if we wanted to create a more complex workflow? A workflow that does the things that we are used to with 1.5 or SDXL? Well, right now what we can do is use LoRAs, for example, or one single ControlNet, and that's Kenny, at least at the time of recording this. And in this case, in order to get these results here, I am using an image-to-image process with a Kenny ControlNet and a Realism LoRA. First of all, in order to get the Realism LoRA working, you have to use the Flux One Dev full FP16 version. And instead of the usual LoRA loader model, which accepts both model and clip, you want to bypass clip completely, so you want to use the LoRA loader model only node. Then I am scaling the image and using the ControlNet candy that you will be able to find in the description below alongside the LoRAs that I'm using. And in order to get the ControlNet to work, I have to keep guidance in Flux guidance to 4. I cannot stray from it. Otherwise, the result would be absolute garbage. That is not definitely true for any ControlNet we will see from now till Flux is supported. Things might be different in the future, but for now, with this specific ControlNet, we have to use guidance 4. Then everything else is basically the same as you would normally with SD 1.5 or XL. We get a result here that uses the same candy outline as the subject, but everything else is changed. Now, this might be completely useless to me because I want to retain the original subject. People who know me know that I am quite fond of creating workflows for product photography. But the thing about using a specific model is that you don't necessarily have, at least inside of ComfyUI, be completely locked out of what's possible with other models. In this group over here, for example, I am loading an IC-Light pipeline that is working independently of Flux. Now, of course, IC-Light is a 1.5 only model, and Flux is never going to be compatible with it, at least as things stand now. But that doesn't mean that you cannot combine the two, at least if you have the hardware for it. So these here on the left is the original Flux generation, and these are all the intermediate passages, and this on the right is the final result. The same goes for any pipeline that already exists. If you are content with the generation you get out of Flux, and you want to further fine-tune things using an SDXL or 1.5 pipeline, you absolutely can. You just need to swap in an SDXL or 1.5 model at a certain point of the pipeline. Now, would it be better to have all of these tools like IP adapters, all the ControlNets I can think of, IC-Light, etc., that are working directly within Flux right now? Well, of course it will. But what I am getting at is that you don't need to limit yourself if you can find ways to circumvent these issues by creating slightly more complex pipelines. So, first impressions of Flux. It's absolutely great at creating stunning images. Also, in my brief experience with it, it's got a sense of scale. It is miles better than 1.5 or SDXL. It's also great at human anatomy. We got the right number of fingers, both with Schnell and Dev, and it's great at typography as well. Here I asked for an advertising photo of a woman doing a thumbs up pose with Flux written on a neon sign behind her, and the prompt adherence is exquisite. Much better than Midjourney, and well, much better than SD3, but that's a very low bar. So given all the limitations that we have said and we have up till now, Flux is an amazing model, and I can definitely see it becoming the base for my future workflows, at least when the time will be right. And for me, that is when I will have a ControlNet adapt and an IP adapter. And while yes, it can be frustrating at times with all of the fussiness that I have never experienced with other models before, I still think that this is a huge leap forward, both in terms of fun stuff that you can do in non-professional settings and in possibilities that it opens for professionals like me. So if you haven't tried Flux yet and you want to jump right into it, you can find all of the necessary infos in the description below. I hope you like it and have some fun with it, and I foresee many more videos on Flux in the not so distant future. I want to thank all of my supporters on Ko-fi. If you like this video, leave a like and subscribe. My name is Andrea Baioni. You can find me on Instagram @RisonoBushi or on the web at andreabaioni.com, and same as always, I will be seeing you next week.